September 28th, 2024, and here we are again with another episode of the HVAC Grapevine. I
What's
am your
going on,
host,
man?
Chris Hughes, or otherwise known as the Duke of Breezewood. Just a little inside joke there. And my co host here, Mike Cianfrocco.
What's
Mike,
going on, my man?
dude, are you packing?
Dude, I like everything else, I'm pretty 5 minutes late on everything, so haven't got the bags packed yet for NCI, but I'm rolling. I went shopping.
Yeah. So NCI Summit coming up this week, right? Monday.
Yeah.
Uh, Bringing my spouse with me. She's coming, so that's going to be a ton of fun. There's a few other couples who are bringing their wives with them, so we're gonna show the wives what HVAC is all about. Can't wait. Ought to be a good time. Maybe she'll even do some booth duty with me. You know
Oh,
what I
that'd
mean?
be cool.
Hey, wouldn't
Yeah.
that be fun?
That'd be
She'll
awesome,
watch
dude. I'm
watch me
excited,
work.
man.
Yeah, I'm pumped up. It's gonna be a fun one. So quickly, tell me about your week, and then let's get into this show, man. What'd you do this week?
Dude, I'm exhausted, man. I'm ready for the winter. Dude, and I was, what is it, Asheville in North Carolina?
Yes.
I'm looking at the temperatures. I'm excited. I saw like
Yeah.
72 maybe one day.
50 at night, 78 during the day. I mean, I'm ready for it too. I think we're all feeling it.
I
I
need
know
a jacket, bro.
I packed a jacket. I
I'm
don't know if I'm gonna
freezing
need
at
it, but
72. I'm freezing, bro. I got Florida blood now.
yeah,
Mm.
it's gonna be welcome to weather.
Yeah,
Although today, walking outside here in Louisiana was pretty nice, if you know what I mean. Good weather today.
yeah.
So, but we do have a tropical storm. I don't know if you've seen it, but there's one in the Gulf and it's hanging on the left side. Who knows what's going to happen there?
Is it
We're
really? I missed it.
gonna see what
Jeez.
happens. Yeah.
Yeah.
Yes, sir. All right. So fun week next week. There's going to be, just to let everybody know, there is going to be some live streams from that conference. So they've set up the live streaming podcast booth at the summit. So be on the lookout. There's going to be some streams in the middle of the week this week. Grapevine's going to be going live at the NCI Summit. So keep on lookout for that and who we're going to
Yeah.
pull in there.
Grapevine is
Michael.
going to be going on a
Yeah.
road, baby.
Yep. So I want to get into tonight's show. You ready?
Let's do it.
Are you ready? Is everybody out there ready?
I'm ready
All
to
right.
roll.
I am too. So
I
here's the
told
fun
everybody
part.
we were going to do flat Earth, but
Well, we could get into that for sure.
I lied a little bit, but
I could get into that. I've watched quite a few random documentaries, docu series on people who believe in the flat Earth thing. It's pretty funny.
we're clickbaiting them.
Yeah.
Got to get
So
those views up.
what I love about the Grapevine, man, and the whole reason this all got started is the title of the Grapevine is because the HVAC industry, man, we just circulate knowledge right through just random channels. And you never know where it's coming from. The trade's always been like that. So hence why we kicked off this show is to like share education. Sometimes we could get things a little wrong. And potentially we did last show. If we brought Cody on, we were talking about duct leakage. And here's the really cool part. Someone who was watching this show was kind of like, that may have came out a little bit the wrong way. I'd like to clean that up. And what did we say? Heck freaking yeah. Like
Love it.
that's the whole point of the show is to correct it, make it right, bring that expert onto the show, lay it out there and get the right information where it needs to go. Because there's definitely too much traffic of bad information out there in HVAC. So that's what
Yeah.
we're kind of jumping into today with some other topics. So the person who's coming on is Matt Milton. So just to give you a little quick bio about Matt, Matt's been in the HVAC industry for quite a while. Here's two cool facts I'd like to lay down about this man. He taught at a community college HVAC. got to have respect for somebody who's done that. That's a freaking hard job to do,
Yeah.
right? And he ran his own HVAC business even while he was doing that. So the dude is rooted in the HVAC. I love that, man. I love guests who've done it. You know what I mean?
Yeah.
So, and I'll let him speak on his role now if he wants to go into it. But this show's about Matt Milton, right? And some fun topics about design. So let's welcome Matt Milton. What's up, Matt?
Hey guys, how you doing tonight?
I'm all right, man. I'm all right. Get through this show, finish packing all my wife's shoes in her suitcase, and then you know, probably have to pay for an extra bag. I'm gonna make
Right
it though.
on. You'll love Asheville. It's awesome out there.
Is
Lots
it?
of
It's
great
nice.
breweries. Yeah, it's a cool town. It's like 4 hours from me, so we did a bachelor weekend there when I got married many moons ago. So it was pretty cool.
Cool. Come on
Nice.
through, man.
Yeah.
Yeah.
So Matt, give us a rundown, man. Tell us where we're at. And you, man, you handled this politely, but like probably too polite, right?
Too
You,
polite.
Right?
yeah. Cody called me. Cody's like, "Hey, man, Matt wants to talk a little bit about duct leakage and like what I was talking about on the show." He said I didn't say it exactly right. He got with me. I mean, the fact that you reached out to him after the show and talked to him about it, that's freaking awesome. Like you did
Yeah.
not have to do that, right? You went
Right.
above and beyond the call of duty. Is kind of how I look at that. And
Yeah,
then
I
the
think
fact that,
it's important for everybody to have the right information. We get a lot of wrong information, so clearing some misconceptions up, I guess, is pretty important.
For
One
sure.
of those kind of detailed kind of guys, so I like to have those details and make sure the people around me have those details too to bring everybody up. We see all too often that there's just too much rule of thumbs and all that stuff that's getting us in trouble, and anything we can do to bring everybody up is my goal of anything that I work with. So
Totally agree.
yeah.
Too many rules of thumbs out there.
yeah,
So Matt, take us down the. I know you've kind of threw some topics at me, so we're going to get into those. But I really
Sure.
want to get into cleaning up that first one, which is
Sure.
about duct leakage and duct
Awesome.
leakage and design. Can you
Right.
kind of tell us where we are? Like, kind of give us the lay of the land, shall we say? Like, just give us the rundown.
Right on. So I'm gonna share a screen here if that's cool with y'all.
Oh yeah.
For sure.
All right. So total
You-
transparency here. I work for MyTech, so MyTech WriteSoft, whatever you want to call us. So I've got kind of all the bells and whistles here. So just FYI, as you're seeing some of this stuff, you may not have everything that I have, or that's kind of stuff. So
Oh man,
just,
super secret information. Love that.
there's nothing super secret here. Nothing you guys can't see. I just have all the modules that not everybody has sometimes. So
That's
let's
awesome.
see if this is going to work out. I've not shared screen with
Sure.
this
Yep.
guy.
If you share, you know what, I may have to give you sharing
I think
capabilities.
it's going to let me do it here.
Okay. Yeah. Once it pops up, and then there you go, and then I'll share it from there. You ready?
Cool. All right. So I think it's here. So this is
There
a
you
right
go.
soft window.
There we
All
go.
right. So what we're talking about, I guess, would be duct settings.
Okay.
Let me go to the right screen.
Let me blow my screen up. I want to see this as close,
Yeah, man.
up and close as possible as I can.
Oops. I am not doing. All right. So let's go. I got to go up here to my floor. This is a big custom house I did for a builder in my area. This was my own project. This wasn't a MyTech project. But let me unlock the building here. If I select a room, get to some duct properties. All right. So I've got this right now set as incorrectly. And I did that just so we can see what's going on. So generally, when we are setting duct tightness here or there, we've got 5 options. We've
Okay.
got the return side. We've got extreme, notable, average, partial, unsealed. Those are our options. Those come right out of Manual J. This has nothing to do with Manual D right now. So
Can I ask a quick question, Matt? Because
Yes,
I'm a slow learner, man. So bear with me. Can
Yeah,
you
man.
show me how we got back to that pop up window?
Sure. Sorry, cancel. So I'm gonna, select my room. This is for WriteSoft, guys. I know there's a lot of other things out there, Elite and Cool Calc and
Mhm.
all the things. This is what I use, so this is what I know. So you got your room properties here. You know the height of the room. What are we heating it or cooling it? Do we have any occupants in this room? And then we've got duct heat loss and duct sensible gain, also latent gains. When you click any of these buttons here, it brings up all that for the duct work. So
Right on.
that's what I'm setting at here. All right. So definitely, depending on how's your configuration of your returns, your supplies, what are we doing, and then also our duct sealing. Now, we all like to think of ourselves as really good installers, technicians, and we do really tight duct work, right? So that's what we all know. We think we're doing a really good job. So we're using the Ring D or something in the duct tester or whatever it is with RetroTech. I've got RetroTech stuff.
Ring 4 Club is what they call it on our
Ring
end.
4 Club. I'm definitely not in that club. I wish I was that good. I'm not a Doug Crawl right now. So
that's right.
Doug Crawl's like got that crazy stupid stuff up there.
Yeah.
But anyhow, so we like to think we're extreme, so we're going to set it at extreme and go with the flow. So that is well and good, but I think we are missing the mark a little bit when we do that for ourselves.
Okay.
So if you dig into Manual J here and there a little bit, it actually gives you some duct leakage per square foot of duct. And if you look at that, let me see if I can pull that guy up. I'm going to pull up another screen. Let me know if you can see this Excel screen.
Yeah. It came right in. Yeah.
All right, cool. All right, so let me blow this up just a touch here. So if we got extreme sealing, that's giving us 0.06 CFM per square foot of duct area. So if you took a 12-inch round duct, figured out the perimeter of that by 1 foot of length, you would get the area for 1 length of that duct, right? So that's what the Manual J is calculating based on that. I don't know too many of us that are doing that by hand. The software is definitely doing that for us. So
the yellow column is your total surface area of return duct leakage, and correct. The other column is so you've done both sides.
Yeah, this is
total surface area.
You got it on the supply side, and the reason I have it on different because it's different levels based on what selection you do make.
Okay.
So if we go down to notable, which is pretty good, 0.09 and 0.15. Average, this is the Manual J default, 0.12, 0.24. Partial would be 0.24, 0.47, and then unsealed would be just like a sheet metal up there with slips and drives that has no mastic, no nothing on it, right? We're crazy.
We're not talking conditioned or unconditioned space at this point. We're just talking leakage of ductwork.
Leakage of ductwork, that's correct. Okay. So it could be inside conditioned space, it could be outside conditioned space. So you're pretty aware of doing duct leakage testing, right? We've got a couple different variables that we can test. We can test leakage to the outside, or we can test total duct leakage. Most people are probably testing total duct leakage because it's a little bit harder to test leakage to outside. You got to do a couple tests, right? You got to match that with your blower door or whatever so you can figure out what the difference is.
Just want to clarify for anybody who doesn't know what we're talking about. When we say total duct leakage, we mean all of the duct leakage that should not be leaking from a duct system. When we say duct leakage to outside, that means if your system has ducts that run outside the air barrier of the home and those ducts leak, that percentage of leakage outside of the air barrier, that is leakage to outside, not to be combined with total leakage. Like there's, correct. So you know.
Right. Exactly. So we've got those parameters. Those are what most of us work by. I do mostly new construction in my my role. I do some obviously retrofit with my contracting business, but mostly new construction in my role at work. So I'm looking at code values. You guys are going to Asheville next week. I'll bring up some Nashville code here or some. Let's see. Let me bring up this guy. So this is North Carolina's energy efficiency code. If we go down here to duct leakage,
are y'all on the 2021? Did they redact it, or did they go all the way for the 2021 code?
North Carolina has some interesting rules. We're on the 2018 code. It's basically a version of the 2012 code
Hmm.
with 2009 energy levels. It's pretty bad. We're in the
Well,
southeast. It's not great, right?
yeah, we fight the same battle. I think
Yeah,
they just like sit around and say, "Hey, in these pile of straws,
right,
none of them is actually the 2021 code. They're all
right.
less. Let's just pick one."
Yeah, exactly. So exactly. So I'm just gonna dial in here. This is our total duct leakage test. We're allowed 5 CFM per 100 square feet of conditioned floor area, and I'll kind of explain what that is a little bit more here in just a moment. But that's kind of the number I want to keep in our heads here as what's allowable by code. So 95% of builders, installers are going to code. There's not a lot of Neil Comparettos out there or,
Right.
Doug Crawls that are doing really, really, really good work. I've got a few HVAC partners in my area. Stephen Raridan does a really good job.
Oh
Um,
yeah, he's good. Yeah,
he's
he's in our group.
there's a few people around that can do that, but for the majority of people, that's just not we're hitting. We're hitting trying to hit that code number if it's actually measured or not. So,
Right.
it's a requirement of code. Is it going to get done? Who knows? Whatever. But
Yeah, and then I test for new construction, and I think we're at maybe that one that's on the bottom. It's like a QN number.
let's see.
You know what? Let me go grab. I've
No
got
worries.
like a bunch of them.
Yeah. Yeah. So I got the duct leak is the outside. We got the outside is a little bit smaller at 4 CFM. Most people are going with the total.
I like to see that your total is lower than 8,
Yeah, it definitely lower than 8, so that's good. It's not completely horrible.
Yeah.
All right. So let's go back to RightSoft here and look at our drawing just for a moment. So this is where we get to decide. Am I going to pick extreme, notable, average, partial, unsealed? And again, in my work, I'm working with production home builders for the most part. They're not doing the best job. They're doing a good job. So I'm probably not going to pick extreme for those guys because I just know they're not going to get there. And we can math that out to see what actually extreme is, right? If these guys test, which a majority of them don't, we probably will find that they're not quite making that extreme. So we think we're good. Extreme, notable, whatever it is, we're going to find here in just a minute. We're probably not doing as well as we think we're doing, unfortunately. So anyhow, so if I go back to my building here, I can find out that my first floor on my manual J screen. Let's go. First floor, I've got 2,969 square feet of floor area. So that's right up here in the top right corner. I'm looking at this yellow column. That's extra yellow. It's all yellow, I guess.
Cool.
I'm gonna write that down for just a second. Let me pop back over to my Excel. Sorry, I'm throwing back and forth a lot.
You're good. I'm tracking.
All right, so here's my first floor. This could be, if this is one system for an entire house, I would look at both floors. In this case, I've got a system serving my first floor. I've got a system serving my second floor. So I'm just looking at my first floor for this house. All right. So in this case, so my 2,969 square feet, I've got this formula set up. It's basically 2,969 divided by 100. And I'm multiplying it by 5. And that's giving me 148 CFM of allowable leakage.
Yeah.
Right. So that's allowable. Right. I can be less. Hopefully, I'm less. That's a lot. Right. But I could be more. The other part of this, I need to know what my supply duct area is for supply and return duct area is. RightSoft actually will tell this to this. I don't know anybody out there in Quick Calc or all those other lands. Do they give you this information? I'm not sure. Somebody can let me know if they do. But if I pop back over here to RightSoft, I've got all my ductwork in the crawl space. So I got to go to a different screen.
Yeah, the last time I used Cool Calc, I changed it from severely, real
Right.
leaky or noticeably sealed, and it barely changed.
Right. Yep. Exactly.
Real
So
strange.
I can go to the properties for my air handler if you're using RightSoft. And again, it's just right clicking, and it will tell me down here the supply surface area of my duct. So I've got 906 square feet of supply area. and I've got 445 square feet of return area. So I'm just using those numbers to figure out where I need to be as far as if I'm building this to code or am I doing a little bit better.
Right.
And you got my brain like working in overdrive, and I don't want to confuse people, but I'm going to save a question I have that goes deeper than what we're talking about now.
Okay. I think I know what your question is, and I can probably explain that. All right. So I'm going to put those numbers in here, and I will share this with you guys if you want to post it or whatever. This came from our tech support guys at RightSoft, so anybody can have it. 906 and 445. I'm just going to copy them down.
Yeah.
I feel bad for those tech support guys when I first got the software.
Yeah. We've got some good guys on the phone. They can probably help you out here.
All right. They're nice.
So this is a fairly large house. It's kind of spread out. I've got a lot of ductwork in this one. This is kind of a little bit outside of, but if I was doing this to code, this one works out perfectly, and I did not plan this, but I would select notable for this guy because that's my allowable based on the area. So it's simply as that. Generally, for most of the smaller, more compact type house, and this one's long and spread out, so there's a lot of ductwork, but more compact, what we're finding is average or partial is pretty much where most houses are leading up. I didn't pick a good example today, obviously.
Okay.
But
so I think there's confusion here that I think we're trying to clean up. And what you're saying is when you go in and you do an input for duct leakage, this is not necessarily based off of your duct leakage test, right? And I think like people go to a duct leakage test, they enter that and they're using that percentage, right? And what we're showing is there's an actual just calculation in the program that says we're looking at duct surface area, and that's how we're going about it.
Right.
So it's completely different than what I test out in the field.
Right. So we can actually enter those numbers, and I'll show you where you can enter the actual test if you have that. But if I'm designing this house to code for my production builder,
right,
this is where I'm going to figure out what I'm going to set my leakage at. And most of the time it's going to be average or sometimes partial, depending on the house. Most of the time it's going to be average, though. The thing that does matter here is you've got to draw this duct system in. So if you do a quick load and don't draw a duct system in, you just use defaults, this number could be a little bit off.
So I feel like I have to ask this question, Matt, before we go further and we get into the selections, because I think this is the time to ask it.
Sure.
Yeah. Take a break, just walk it back. Yeah.
So I cut my teeth on this program. And I remember manipulating my design velocities, and I would reduce them, which would artificially enlarge my ductwork, which would basically reduce my pressure drop, right? On the system, the system's total external static pressure would go down because I reduced my velocity limits. That's going to increase my duct surface area. So does the calculator in the tool continue to spread out the leakage because I made my duct surface area bigger, or does it take velocity into consideration at all? And I'm thinking not, because this is the calculator I'm thinking. And so it's not looking at velocity, it's looking at duct surface area only, right?
So this is probably one of the last settings that I do when I'm finishing my load, is this one, because if you've drawn your duct system in, it's going to completely, as you change things and remove fittings or add fittings, duct sizes are going to increase or decrease. And so at the very end, okay, this is how much duct area I have. Again, I'm probably going to start as a defaulted average. That's kind of got my template set up as, but if I see that I need to increase or decrease, I can then do that.
Yeah.
And you might find that you're somewhere in the middle of these, right? This is just a number based on these settings or out of Manual J. So if I find that I'm coming up at 180, I'm probably gonna, I don't know if I want to add a little to my duct, or do I want to be a little more conservative? I think it's probably going to depend on who's doing the work, right? If I know that it's a contractor that does a pretty good job, I'm going to bump it down. If I
Right.
don't know who's going to be doing the work, I'm going to probably bump it up to give them a little bit of cushion, right? I don't
So
want to. I don't want to add a bunch of cushion, right? You don't. That's like rule number one of Manual J. Don't do that. But when I'm going to decide if I don't know who's going to be doing it, it's hard to guess.
Well,
Right.
does the calculator take into consideration the double whammy from duct leakage? Like, does it? You obviously lose capacity if you're outside the envelope,
Right.
but does the math calculate the infiltration impact that's going to come with that as well?
No, Manual J doesn't do that. Those double.
Okay.
So the software is written straight, word of mouth out of Manual J. So Manual J doesn't account for both of those, unfortunately. At this point,
Well, yeah. I mean,
Wow.
it accounts for infiltration based on design temperatures, height of the building, blower door score, or whatever you set as tight, leaky, whatever. There's more than one way to enter, building tightness
well,
there.
I let me say this. I could probably argue both sides of the fence on this one, right?
Mhm.
Because there's this, I mean, I think what people have to understand is you got to start somewhere and you got to have some type of data to make a good ballpark suggestion for the load. And that's
Right.
kind of what we're doing here. And so, like, in one argument, I could argue for um, this method, and I could say, let me collect my thoughts here. I could argue this method, and I could say, they should account for the infiltration coming in. They should show the impact. That should be part of the load, blah, blah, blah. Then again, you could say, well, this is looking at duct surface area. It's not exactly going to be uniform pressures through the system. The duct leakage could be way less. We don't know. So then you over account for it. So
Right.
there's different ways you could look at this.
Right.
And there's no like just perfection move to duct leakage, I guess is what I'm saying.
No, that's correct. You've kind of got to have some understanding of, if you're the contractor doing your own loads, how are my guys installing? If I'm using, all sheet metal, it might be different than if I'm using all flex, right? There could be things like that. This doesn't take into account, what am I using here? So if you're using
Right.
sheet metal,
Yeah.
you got joints every 5 feet, right? Versus 25 feet of flex. So
So
the flex
we
system could be just as bad as a sheet
Well,
metal system.
we got
right?
a lot of new guys into the group recently, so let's just kind of like give this a basic overview. This is your Manual J. Somebody's designing a house before it's built, and the engineer or the load calc guy needs to account for some type of leakage, right?
That's
right.
correct. Yes, we got to come up with something. Yes.
And
Something.
this is one methodology, which I think, Matt, if I'm not mistaken, are you taking us down the road of other methodologies or processes you could do inside the program?
Yeah,
Like,
there's a couple other ways to do it. So this is if you're using the extreme notable average partial instance, right? So that's your kind of your 5 options. So this is more driving you towards what should I choose based on the way that I know that I do my work. If you're not testing anything, it's hard to figure out.
Right.
If you're trying to meet code, which is what I'm trying to design to, because I'm working in these builders all over the place. I don't know how they're building, so I've got to get them to meet code. This is how I'm designing for them to meet code. Basically.
And some builders know they're going to do like some Energy Star stuff, so you could account for that right off the bat. But a lot of time, the engineer just doesn't know.
Right.
So,
exactly.
Cool.
Yep. Funny you mentioned Energy Star. Let's look at that for just a second. So it's surprising.
I see the calculator at the top left. That Energy Star is the So just so everybody knows that the calculator in the top left is not working with the calculator at the bottom. That's an independent calculator.
Right. These are independent. That's correct. And I've just got this as Energy Star approach. This could be code approach, right? Because I use code as 5 air changes per hour or 5 CFM per 100 square feet. If we go back to Energy Star, it varies. If you're tested at, I'm going to go to final because that's generally when it's tested. It doesn't get tested at rough end for most people, right? And this depends on the number of returns. This is Energy Star. This is supposed to be an efficient house, right? 8 CFM per 100 square feet if you got 1 or 2 1 or 2 returns up to a maximum of 80. Or if you got 3 returns, this is going to be a big house, up to 12 CFM per 100 square feet, or a maximum of 120 CFM. So Energy Star is even a little bit worse than what my code is in North Carolina. It could be more on par with what some of the other states are, but it just really depends. So some of these designs for Energy Star may not be that great.
So it's
Wow.
8, but let me make sure I'm saying this right. It's 8 for 1 to 2 returns, which is probably going to be our most common.
Correct.
But when you test at final, they also make you test the duct leakage to outside, and that has to be less than 4, I believe.
Not in my state.
Duct
It's
sealing.
just duct leakage, man. I do
This is
performance
total duct
like
leakage. It
ERI.
doesn't say it to outside. This is just total duct leakage. This isn't to
Yeah.
outside.
Just a duct blaster on the return, and that's
Yep.
it.
I don't recall anything where it talks about leakage to outside. There's footnotes down here, but we can check on that. But I don't think
I think it may be. Look at that next sentence right under the table. It says, in addition, sealing specific to achieve radar must measure duct leakage outside when tested at final. That is the greater of or less than 4 CFM per.
Oh, there you go.
So they've got to hit a duct leakage to outside target on top of the 8 CFM or less for 100.
Correct.
So they got to do two.
Yeah.
They got to do 2 tests essentially.
Right.
If
So
they're testing at final.
Correct.
Still though, 8 is
that's a lot.
Yeah, it's a lot. Yeah,
it's a lot.
It's a lot.
So yeah. So again, this is more of a tool here to estimate where you're going to select as far as your tight, semi-tight, whatever, extreme, notable, average, partial, unsealed. So that's kind of the goal here, is to find a target that you're going to make, that you're going to find.
So, question for you, Matt. If let's say job's done, I want to go true up my load. Can you show me in the program where I go in to make that input for the duct leakage? And does the program do duct leakage to outside as an input in that program? Is like, can you put them both in, or do you put one in, or how does that work?
It is just one value.
Okay.
And because depending on how you've located your, sorry, I'm trying to get to the, I got to go to the right room. Depends on how you've located your room, is where it's going to pull that air from. So this is an enclosed, this is like a encapsulated crawl space in this case. If I was up in an attic, that's going to be outside air, so they're going to take that. And I don't know that it separates between the two.
I got you. So it's basically when you build the duct, draw the duct in the room essentially is considered in the envelope or out of the envelope, and it knows if it has a vented attic above it or not. And so whichever way that duct is routed, it's being determined automatically.
Right. So, well, you've got to determine that. So you could say, conditioned space, because it doesn't know that you're putting your ducts in a crawl space and you're on the floor above. So you've got to set those parameters as to where it at. As far as load goes, it understands that, but it doesn't understand where your ducts are. So you've got to choose that. So
got it.
So if it's an encapsulated attic, will you take a penalty if there's duct leakage?
So your encapsulated attic, you're going to get a little bit, because your encapsulated attic isn't the same temperature as your conditioned space generally. So
true. Yeah.
That's the way that this one calculates. If you are completely conditioning that attic, which I've done some, then I would set that as conditioned space and I wouldn't worry about it.
Set it as conditioned space, and there'd be no penalty in the software. Okay.
Correct. Because when you put it at conditioned space, it basically zeroes everything out as far as leakage from that system. Okay, right. Cool. So, caps, I forget what.
Yeah. We were in Florida. They said you didn't even have to test the ductwork for leakage if it is an encapsulated attic, and then they repealed it.
Right on.
Last year.
I agree with that. I think you should test even in a conditioned space. And the reason I say that is because it's not just a situation of loss of capacity. It's if you don't, let's say you go into a house and you don't test for duct leakage and you create, let's just say you create a negative zone where there's an 80% furnace and a natural draft water heater. You'll backdraft the appliances
Right.
if, you know what I'm saying? It's a possibility of that happening. On top of that, you have also have the issue where you're just not delivering the right amount of comfort cooling to a space. And so you
Right.
could have, you could have a hot spot based on not delivering the right amount of air.
Yeah.
Yeah,
So I'd
because I'm
argue for
passing code on this house that I just pulled up. One of my jobs. It was 100 CFM on a 3,000 square foot. So if we're not testing, we could have 300 CFM going up to the conditioned attic, and then you're losing that. Like you're saying, you're losing that going to all of the drops, and it's just a
Right.
it's a reduction in CFM. Yeah, that makes sense.
Exactly.
But we got to talk about it because it gets confusing, and then you're out in the field, and if nobody's talking about it,
Yeah. All right. So let's true this up for what we actually test.
right on, man.
So if you come down here towards the bottom of this dialog box, you've got leakage type. So MJ8, that's going to be your extreme, notable, partial, whatever. But you
Cool.
can also choose percentage or CFMs.
oh,
Probably
okay,
would choose
wow,
the CFMs in your case. This Energy Star is on some dated Energy Star. We need to update our software, but Energy Star is changing so much that we haven't been able to keep up with that.
Yeah, I bet. Yeah.
So I would either use this CFM or percent. So
Okay.
I'm going to click CFM, whatever that is. Something to note. When you enter this in here, it will give you a percentage over here on the right side, right? This
Mhm.
percentage is percent of blower CFM. So
So
if I've got 1,000 CFM coming out of my blower, if it's a 2.5 ton system nominal, we'll say, right? And I put 600 CFM, I've probably got a 2.5 ton here. This might be a 3 ton.
Matt,
Yes.
easy question. Design CFM or actual CFM?
Actual CFM, what you have
Okay.
entered for your blower, right?
Okay.
So let me just step back one step here. So I might go to my blower, or I can do that actually here. I'm moving 1,255 CFM. This is a 4-ton system, actually. Yeah, I've got both of them set the same. 1,255 CFM. So
Is
that's
that
what
an
I'm using for this
is that
system.
an inverter?
This is a
Oh,
Oh no,
it's
it's
a
a
TR40. Yeah.
it's a 14 seer.
yeah
So
14
probably not
series
so not non-inverter.
non-inverter. Yeah, just single stage. Yep.
Seems like man, it's these manufacturers looks like the airflow is getting nominally lower.
Yep, they're getting lower, and I have to do that probably in my neck of the woods to handle humidity, like you all
Yeah.
do. So, but yeah, so let's go back here. So when you enter that, don't get so wrapped up around those percentages. Oops, the percentages or whatever. Enter in
So
what your test is.
so see when we're saying system leakage, if you click CFM and you put in
Right.
that number, that is the leakage number that you measured at 25 pascals from a duct leakage test. That
That's
number
correct.
goes there.
That's correct. So if
Okay.
you measured 100 CFM here, whoops, I hit return. If you measured 100 CFM, I would do that for both heating and cooling, right?
Mm-hmm.
Yep.
So that's about 8% of my blower CFM, right? That's
Oh,
not
wow.
8% as by like 8 CFM per 100 square feet percentage kind of deal.
Yeah, and not to be like related back to floor area or anything
Correct.
like that.
Right.
Like this
That's
isn't
correct.
like
Gotcha.
this isn't like Energy Star percentage. This is
Right.
percent of actual CFM.
Yeah, I thought for a long time for myself, I was like, well, if I put percent in, that's what it means, right? It's 4
Yeah.
CFM per 100 square feet or whatever. I'm like, oh, geez, that's not right. So
I was thinking that.
Gotcha.
Yeah.
right, exactly. So you can, and I've got on my calculator here. If you go the other way, if you got your design CFM here, this is 1255, right?
Mm-hmm.
So you can work it either way. If you needed to figure out a percent and your total leakage was 100 CFM, right? So that's 7.97, same percentage. I'm just working it back the other way. So, right. So if you needed to work it either way, I've got that set up in there just so I can figure out what that is. If I wanted to enter percentages or if I wanted to enter CFMs. So
cool.
Which is
that's a handy dandy little calculator right there.
Yeah.
I wonder if that's in Dustin Cole's massive worksheet.
I don't know.
You never know. You never know.
Sure looking at it.
Yeah.
That's cool. That's interesting. I did not know that, man. That Writes Off had all that in there.
Yep. So you can actually enter that stuff, and those numbers will swing your load pretty considerably, right?
So, that's what I was going to ask you. Go from extreme to.
Yeah. So let me go back to this MJA, and we can look at the load. Whoops.
Yeah. What are we looking at as far as BTUs, man?
Let's see. I've got this one broken out into zones. Let me get it. All right. So we'll just look at cooling here. Can you guys see that load meter okay? I've got almost 37,000 BTUs of sensible and 5,000 of latent. So if you go through and
we can handle that,
right? I'm going to select all my rooms, so everything gets adjusted. And I'm going to say that I'm going from extreme to, I'm going to go to average because that's probably more realistic. And picked off my thing here. So not a huge bump. Not a huge bump for cooling.
Yeah, no, just a couple
little bit bigger heating, right? So it's about 500 BTUs and about 1,000 BTUs latent.
Oh, not bad.
So it's not a huge bump, but it does make a difference. It's probably more of a difference on heating.
Yeah. I wasn't. It's funny how I bet like half the people in the chat are probably staring at the heating bar, but because I live in Louisiana, my eyes were focused on the latent load.
Right.
Yeah.
I'm just like, what? Like I only see one dial, and that's the blue one.
Yeah. If I change this to a vented crawl space, it's probably a big deal.
Yeah.
Let's select all rooms again here.
So Matt, I do want to pick your brain about one other thing while we're on this topic. I feel like this should segue into a kind of a topic we should discuss, and that's not stopping at manual J, because all of this is calculated basically on a design flow. When you don't get your design flow from manual J, you get your design flow from manual S. So would you mind taking us down the road of like why you should probably not stop at manual J and use the kind of artificially generated CFM and get to a real design CFM?
Right. Cool. Yeah. So if you stop at this point without drawing ductwork in, now granted I've got ductwork drawn in here, it will give you a room CFM of what you think it's going to take here. So the software will come through and add all those room CFMs up. And this case, it might tell us that I need, if I go to my equipment, I might need, this is a 4-ton system. I might need 1,600 CFM, right?
And
I've actually got,
sorry.
No, it's okay. I've actually got 1,255, right? So that's a pretty big difference of CFMs, right? You're 300 and something CFMs, 100, 250, whatever. So that's a big difference. That could adjust your duct sizes here and there. So
I always wondered how the program spits out an artificial CFM before you do a manual S. Are they just using like a nominal flow per ton as like just like a ballpark to get you started before it's corrected from a manual?
There is a calculation in manual J, it might be manual D, that kind of gives you a rough idea of what that is.
Okay.
I haven't dug in to bury that because I'm always going to get a specific one. I can look that up and find that out. But
I obviously haven't looked it up either.
Right. I don't remember which manual it is. I think it's manual D. Actually, will tell you how to figure that out. It might be in J, but I think it's in manual D. But if you don't have your equipment data, you're not going to have the right thing, right? So this is me. I put everything in right soft, so I know if I need to print it, I can go back to it. So
Oh, sweet. You drop all your
yeah, so
expanded performance data for your
right,
equipment selection. That's yeah,
exactly.
dude. That's
Right.
What?
So I'm
that's
going in, figuring out,
baller.
what
That's a baller
CFMs,
move, dude. Baller
right?
move.
And it's just because in case I got to go back,
Right. It's
where
in
did
there.
this come
Yeah.
from, right?
Heck yeah, man. That's
That's
So
that's
crazy.
that's
yeah,
awesome.
so
I've
I
never
just go through and add all that stuff in
I've
there.
never seen anybody put it in the same
Oh, he's
like
got the
all in
quick
one
pop
dump. That's
models,
cool.
the train filter models right there.
Yeah.
Nice.
So this was a train system, obviously. And I've got all kinds of stuff here. I've got my pressure drops, like the pressure drops, my
Yeah.
evaporator,
Right. Right.
um,
That's called
heating and cooling.
it's like backing it up,
Yeah.
doubling down.
At the time, we didn't have the train data in there. We were missing train data for several years. So I was going out through and hand calculating it. And I set up a calculator that dealt with train data because it was a pain to actually do that by hand. I mean, I'd spend hours doing my manual S. So there's all
Mhm.
my data there. But anyhow, so yeah, so I just go through and actually find what the blower is going to actually give you, right? If
Right.
Mhm.
Riceoff says you need 1600 CFM, but you pick your 80,000 furnace at a half an inch, well, you're not going to get that probably, right? And I think I ended up designing this at 0.7 instead of a half an inch. So I'm over here at 1255 instead. Um, but you've got to pick a number that the blower is actually going to deliver, or you've not got an accurate load, or you've not got an
Mhm.
accurate duct design. So, is it a
Yeah.
huge deal? Maybe not. But if I'm working with a production home builder, they're wanting the smallest piece of duct that they can put in there because they don't want to spend any extra pennies on anything they don't have to, right? So trying to be as aggressive, what's kind of what Manual J says, is be as aggressive as possible, right? So
Yeah,
find
and
out
there's
what it's doing.
it's been my experience that from like installing a design system, typically the pressure drop will be less than what you designed
It
for.
will be
So,
less. Yeah.
so like and I'm not saying you're making the wrong move. Like if you go at it at point 0.7, you're more than likely if they do a pretty decent job, they're not going to have point 0.7. They're going to have like point 0.5.
Yep.
Uh,
Yep.
you know.
Again, I got to be able to repetitiously repeat if I got a problem. This is how we figured this out. This is where it came from. And I agree with you. A lot of times you design for zero point 0.7 and it comes in at 0.5. I've heard that a lot. And
Mhm.
that's because you're looking at your fittings. If you go to Manual D, you're looking at your fittings. The supply fittings are based at 900 feet per minute, and 0.08, I think, is the friction rate. Your
Mhm.
return fittings are based at 700 feet per minute at 0.08 also.
Yeah.
So if you actually have a lower velocity than 900 feet per minute in your supply side, which I hope you do,
Well,
really noisy side.
I we'd need a whole nother podcast, man.
Oh, that's the weeds. You're getting into the weeds.
Yeah.
There's
Oh yeah.
corrections you can do, but you can't do that by hand. You got to have a software to do that.
Yeah. Well, I would love to know when those were formulated, how the testing was done. So we did
Right.
some tests at headquarters, and I feel like I did a webinar on this. Maybe I did, maybe I didn't. But like a 90 is calculated,
Mm-hmm.
but there's two different kind of ways you could test a 90. You could test the pressure right in the 90 and right out of the 90, and you might get an EL of say 90 feet.
Right.
But if you test 10 feet away from going into that 90 and then 10 feet going downstream from that 90, and you subtract the 20 feet of pipe you added to it, you'll get a lower pressure drop than if you tested right at that 90. And what we found out was that air, when it hits that 90 and pushes against the turn, there's a whole bunch of pressure that slams against the wall and the pressure gets really high. Then when it
Right.
goes down the pipe, it levels back out. So it's like it's an artificial static reading that happens right at the 90. But if you put two 90s back to back, you're probably at an EL of 90 feet.
Oh yeah, for
I'm just
sure.
saying it's possible. So it's like, well, which one do you put on paper? And
Sure.
I would say, you know, padding Manual D on the back for this one, I'd go with the worst. Why?
Yeah.
Because you don't want the call that, hey, my ducts are too small. If you get
Right.
the call that, hey, my duct's too big, you're going to say, okay. Like
Oh, okay.
Yeah.
not a huge issue there.
Yeah.
Definitely. And if you're doing Manual D by hand, it's the worst case because you're figuring out the total longest length and working everything based on that one longest length. It's kind of like gas piping, right? So you're really going to be oversized. Brightsoft goes in and figures out the length for each individual run, supply and return. So
Yeah.
there's an actual friction rate for each run.
Yeah,
So it does optimize a little bit, but you're still not getting that velocity and that kind of stuff included in that. So
yeah, there's like a name for that. I can't remember the name of it, but I know what you're talking about. Where it's like it looks at all the runs at one time and calculates. That way you just don't
it's
have
like
like super big ducks.
So longest length method,
Yeah.
basically.
Hmm.
Longest length method.
Interesting.
So it works at the worst case, and you design everything for worst case.
Yeah, there's that, but there's a. I'm boring you, man. I'm just trying to think of the name of it. There's a name for when each duck gets calculated. So even your short run isn't like a 12 when it just needs to be, say, a 10.
Right. It's a variable friction rate.
That's it. Maybe that's the title I was thinking of.
Yeah.
Cool.
Yeah, that's
really important.
Stuff.
You know, another thing as we're talking about that, having the data in there is, as you guys know, you guys have seen it, but you can't pick a 2-ton coil that goes with the 2-ton air handler blindly, right? If you start doing that, you're trying to run a small evaporator in this case. If I try to run a 2-ton air handler with around this one's a little like 860 CFM, you're losing a lot of static through that evaporator, right? So definitely got to keep an eye on that. Using the smallest evaporator that will work, just because it's an AHRI matchup, might not be the best thing for your system, right? Got to sometimes pick that bigger one just in case, so you can get a little bit more pressure, so you don't kill your blower.
Right.
It's really critical.
And keep in mind, there's 2 pressure drops for these coils. So if you're listening, there's a dry coil and a wet coil. If you're designing for cooling, if cooling has your most resistance, make sure you're picking that wet coil or doing the correction math on that pressure to put that worst case scenario in.
Unfortunately, I haven't seen, for these train coils, I haven't seen a dry coil correction, unfortunately. It's probably, if you look like at a Goodman coil, they've got the dry and the wet. Carrier, Bryant, they have a correction, I'm pretty sure, from dry to wet.
It's been a long time since I looked at a train coil chart, but the last one I remember looking at was dry coil with a wet correction factor, and they had like 3 different correction factors for all of their coils, which I thought was kind of odd, but it worked. That's what they did. So it's real interesting to see that data say, like, you have a wet coil data sheet, which I like that. I prefer that. I don't like it when manufacturers kind of say, we don't need another table. Let's just give them this number and tell them to use it,
Yeah. So, I mean, obviously a wet coil, that's going to be your max pressure drop. So a dry one, you're in the green a little bit. So
yeah,
that's the way that I see that one. Unfortunately, I'd love them to have both, Manual S says you're supposed to have all these things, and then you go out in the real world and maybe depends what the manufacturer wants to give you.
Yeah. So here, I want to hit one more fun one before we close out the show, man.
All right.
I'd like to hear your spill on grills, because I know that most people probably estimate grills, and they also have homeowners that are like, hey, I want my grills up there, right? There's a lot of grills you could buy that pressure drops are maybe not even presented with the grill purchase, like the wooden ones you'd buy online. I mean,
those are a challenge for sure.
So this would be manual T, is that right?
This would be manual T. Yep. I think as an industry, we severely undersize return grills like crazy.
Man.
That's probably one of the biggest things that we see. Manual J or manual D, it says it now, but they've really made it clear. There's a revision coming through from ACA. They're working on another revision of it, but they've made it pretty clear that 300 feet per minute through a filter grill is as fast as you can go.
Wow.
Oh,
so that's
a filter grill. That's not a grill without a filter, but that's a filter grill, and that's what most people are putting in there. So
Mm-hmm.
To get a 800 CFM or a 2-ton out of a filter grill, you're going to need a 20 by 30 grill to make that happen.
Yeah,
About
yeah,
Pretty
time. All
crazy,
right.
right?
yeah.
You're going to need some big
Nice.
grills.
These 5 tons, man, they're going to be shoot. You're going to start putting 24 by 30s on both sides of the house.
Yeah,
Yeah.
for sure.
Yeah.
Yep. I've
They
got
just
another. Let's see
never
if
get
this
enough
will come up
airflow,
here.
man. It's crazy.
Um, I've got all these calculators I've built, but I do have another one that I use for filters.
My poor homeowners are throwing in the fan killer
Right.
5000s in there. Oh, there you go with the Filtreats. There it is.
Right. So I went through, I went to Home Depot and contacted
My
Filtree and Flanders and all
MPR.
the people, you know. Also, these things point to on these filters. It's crazy going
I like
across
the
these
black
guys.
one with the
They have
charcoal.
charts based on different velocities or whatever, but for the most part, point two. It could be higher than that.
Woo.
Yep. For a single 1 inch, some of these are big ones. But I built a chart here that just has, this is how much air you can get through a 12 by 12 or whatever in a few different manufacturers, right?
Oh
Hart
yeah,
and
I got that
Cooley,
Hart and Cooley one. Yeah.
right? Pro Select, True Air. Those are the three biggies that we use primarily. So, 14 by 20, you're getting not quite a ton out of a 14 by 20. Not quite a ton. So
Okay, gotcha.
we use a lot of 14 by 20s.
Let's see, 20 by 20.
20 by 20, you got not quite a ton and a half out of a 20 by 20.
Okay.
That's based on, this is come from their data, right?
And that's all Filtrete on the right.
Yeah, so this is just
True
supply
Air.
grills and how much they're rated for. These over here, I just went through and dug through a bunch of different filters and tried to get their data. I've got data sheets for all these things, but just to make it easy, you started getting into, these are like 2-inch filters, right? These are kind of the ones you buy at the supply house.
Yep.
Yeah.
For like commercial.
I
modified my return grill a while back to take that 2-inch Flanders.
Right.
Yeah.
You could always trust that rock stopper, though, man. I think I seen it. Was it 0.07?
The rock stopper, yeah, it's pretty.
I was actually surprised to see it that high.
It's high. It's higher than you think. Yeah, just
There it is. There it is.
I remember measuring one of those on a house, and I think I got like 0.03. It was a big one,
right?
And I was like, "Dang, man, this thing's like non-existent."
Yeah,
I like the name. It's the Easy Flow.
Yeah.
Yeah.
If you're looking for airflow,
it's good marketing.
Yeah. So the manufacturer has charts on all these, but I just kind of went through, and this is a basic size that we're using, and I put that in there just so I can know. Generally, when I'm designing, I'm 0.2 for a 1-inch filter, and
0.2.
Then if you could be better, you could be worse, but then if we're going to a media, which I try to push most people to media.
Matt, you've probably seen way more designs than I have in my lifetime. Would you say that the majority of all probably maybe mistakes that could be easily fixed would be upgrading the filter grill and the filter?
Oh yeah, for sure.
That would be like just the easy dynamite move. Just super large. Just make it as big as you can. Almost get rid of it
as big as you can. Right. Yep. Exactly.
Yep.
I think then everything starts to work.
I think Allison Bales had a rule. I think it was 2 square inches per CFM or something like that. Maybe that was instruction.
I've heard that. Yeah,
I saw that video.
That's a big filter. I think, I went to a construction instruction class, and I think they were like, something like that, and then designing your returns for like 0.03 or something, just something stupid. So you had these huge returns, but that makes a huge difference to get all that air back there. Definitely quiets it down.
The wall return, man. Just have a whole wall. You know what I'm saying?
So, again,
dude, that's what I was saying at the symposium, man. Make it like a MERV 20.
Yeah.
And just do 8 feet tall. Just paper.
Yeah.
Done.
Yeah, and then just to wrap up here, I know we're running out of time, but to wrap up with like supply grills, you just got to look at the data. There's really no
and the throw.
And the throw.
Make sure you're getting the throw, especially if you're feeding air from the bottom of the floor and throwing it up, right?
Yeah,
like
exactly.
They have the most challenge. So
Ed John Walker said this too. I think that it's the Hot and Cooley Royal Airs. Those are the best ones. They're expensive, but they're the best ones
Yeah.
for throw. You just get a basic, $10 brown two-way floor register, and those things will throw 4 or 5 feet. At you know, it's
Yeah.
it's amazing when you start looking at the data what they actually do. So
I like those
um,
ones where you like walk on them and then it just closes the air because they got
yeah,
the little thing. That's nice.
yeah, yeah, yeah.
Well,
Floor
man.
registers are tough. Curve blades for ceilings is ideal.
Yeah,
Adjustable curve blades.
Yeah.
yeah,
I'm
they're
not getting
nice.
that in the production world, but in more of a custom type house, definitely can usually get that in there.
Yeah,
So
Man, I just want to say, man, thanks for coming on the show and dropping some knowledge bombs.
yeah,
sure,
dude.
That was awesome.
I'm
That
screenshotting some of that stuff he had on there. I'm
yeah,
screenshotting it. I'm putting it in my folder. So
heck yeah.
appreciate you showing us that stuff. That
yeah.
was awesome.
Yeah. So man, thanks a bunch. Thanks for coming on. Thanks for setting the record straight. Appreciate it, dude.
You're very
Awesome
welcome.
sauce.
Thanks, guys, for having me. Appreciate it.
Thanks.